Forget mathematical tables and forget calculators. If you understand these three angles, many trigonometry questions will be bonus marks for you. Today, I want these three angles to be your best friends. Let's get started. Let's consider this triangle ABC. Let's call this A, B, and C. This triangle is an equilateral triangle. It means say all the three sides they equal. Make we talk say AB na 2, the length from A to B na 2, from B to C na 2 also, and from A to C is also 2. Because the three sides they equal, the three angles will also be equal. So angle A will be 60 degrees, angle B will be 60 degrees, and angle C will be 60 degrees. But assuming we now divide this triangle into two equal parts like this. Remember say BC na 2. But since we divide it into two parts, let's call this place D. BD will become 1. DC will be 1. What about this angle? Remember this angle na 60 before, angle A. But as we don't divide that into two equal parts, this side will be 30 degrees and this side will be 30 degrees. So let's take one part of this triangle. Let's take triangle ABD. Remember that AB is 2, BD is now 1, because we don't divide them into two parts, and angle D is a right angle triangle. Also, remember that angle B is 60 degrees, but angle A is now 30 degrees. So this 30 degree where you see for here and this 60 degree where you see for here, and then be this, so angle 30 and angle 60. But something is still missing in this triangle, AD. What is the length of AD? We don't know yet, so we need to look for it. How do we look for it? We use Pythagoras rule. Using Pythagoras rule, the rule talks say BD squared plus AB squared equals to AB squared. AB na 2, BD na 1, but we don't know AD. So we say BD is 1 squared plus AD squared equal to 2 squared. 1 square is 1 plus AD squared equal to 4. Next, we will say 1 plus AD squared minus 1 equal to 4 minus 1. This 1 and minus 1 will cancel out. So we have AD squared equal to 3. 4 minus 1 is 3. Since now AD we dey look for, this one is AD square. So we need to remove the square, make it remain AD. How we go take do am? We go take square root of both sides. So we say square root of AD squared equals to square root of 3. Now this square root will cancel this square. Wetin come remain na AD equal to root 3. No need to look for the square root of 3. We will leave it like that in the form of surd. So we now know the length of AD. The length of AD is root 3. Since we don't sabi the three sides of this triangle, let's use them to define these angles. Whenever we are dealing with right angle triangles with included angles, what should come to our mind is SOHCAHTOA. SOHCAHTOA. And what is this so? So is sine, ka is cos sine, and toa, the t here, is tan. So what is sine 30 degrees? What is cos 30 degrees? And what is tan 30 degrees? Let's find out. So let's start with sine 30 degree. So SOHCAHTOA they tell us say sine na opposite over hypotenuse. Sine is equal to opposite over hypotenuse. So for this triangle, wetin be the opposite? The opposite na the side wey face this 30-degree angle. Say am 30-degree angle. If you trace am come down, BD is opposite to angle 30 degrees. So the opposite is 1. What about the hypotenuse? The hypotenuse is the longest side in a right angled triangle. So this side BD might be the hypotenuse, and it is 2. So sine 30 degrees na 1/2. What about cos 30 degree? Cosine here, which is cos, is equal to adjacent over hypotenuse. See, I'm adjacent over hypotenuse. So which side be adjacent? Remember, say AB na hypotenuse, BD na opposite. It means say this other side AD na adjacent. So the adjacent na wetin? Na √3, and the hypotenuse na 2. So adjacent over hypotenuse na be √3/2. That is cos 30 degrees. Tan is TOA, opposite over adjacent. So tan 30 degrees means na opposite over adjacent, and we don see say the opposite na 1 and adjacent na √3. So tan 30 degrees is 1/√3. What if the angle na 60 degrees? So we are still using the same triangle to define sine 60 degrees, cos 60 degrees, and tan 60 degrees. Now that our interest has shifted from 30 degrees to 60 degrees, some things have also shifted. For example, which side face this angle 60? Now this side AD na face this angle. So AD don't become opposite. Hypotenuse no dey change, because the longest side na be hypotenuse. Always hypotenuse na the long pass. So AB na hypotenuse, and na 2 e be. If this na hypotenuse and this na opposite, it means say this one BD na be adjacent. So wetin be sine 60? Always remember sine na opposite over hypotenuse. So sine 60 degrees go be opposite √3 over hypotenuse 2. What about cos 60 degrees? Cos na adjacent over hypotenuse. Adjacent na 1 and hypotenuse na 2. So na cos 60 degree be that. And tan 60 degrees. Tan na opposite over adjacent. Opposite √3 over adjacent 1. Anything divided by 1 remains the same. So tan 60 degrees na √3. What about 45 degrees? Let's find out. We go use this square take find out angle 45 degrees. If I say for square, all the sides dey equal. Now wetin be the length of the side? Make we assume say AB na 1. That means BC go still be 1, CD go be 1, and AD go be 1. For every square, all the angles still dey equal. In fact, they are right angles, meaning that each of these ones na 90 degrees. But supposing we can't divide this square into 2 equal parts from A to C. This one don't give us 2 right angle triangles, so we get triangle ABC and triangle ADC. So let's take one of them. Let's take triangle ABC. This is B and this is C. Remember, say AB na 1 and BC na still 1. Angle B na right angle triangle will be 90 degrees. Remember that angle A used to be 90 degrees, but because we divide it into 2 equal parts, this side will be 45 degrees. So here will become 45 degrees. The same thing happened at angle C. It was 90 degrees initially, but since we don't divide them into 2 parts, wetin we can remain for this side now 45 degrees. So AB now 1, BC na 1. What of AC? What will be the length of AC? We don't know am yet. So we go use Pythagoras rule. Side AB squared plus side BC squared is equal to side AC squared. What will be AB? AB na 1 squared plus BC 1 squared equal to AC squared. 1 squared is 1 plus 1 squared is also 1. This one will give us AC squared. 1 plus 1 na 2. So 2 is equal to AC squared. Now we need to remove this square so that it will remain only AC, because now AC we need. So we will take the square root of both sides. Square root of 2 is equal to square root of AC squared. Now square root, they always cancel square. So what will remain for here? Now AC equal to the square root of 2. Now let's just change their position. So therefore AC is equal to root 2. So this AC we see for here, the length na root 2 or square root of 2. Now when we don't know the 3 sides, we fit use them to define angle 45 degrees. Let's do that. Now this is the same triangle we have been using. AB is 1, BC is 1, and AC is root 2. Now let's use this triangle to find sine 45 degrees, cos 45 degrees, and tan 45 degrees. How do we do that? Always remember sine 45 degrees is opposite over hypotenuse. Where the opposite for here and where the hypotenuse? Make we start for the one we know well. Hypotenuse na they always long pass. So hypotenuse na the root 2. Hypotenuse na be this side AC. What about opposite? Opposite on the side wey face the angle. If we use this one, BC na the opposite. And what will be the length? Now 1. Even if we use this one, AB na be opposite, and the opposite na still 1. So we fit use anyone wey we like. So make we talk say we dey use this one. Opposite go be 1. It means say this side na the adjacent, and the adjacent na still 1. So sine 45 degrees mean opposite over hypotenuse. Opposite na 1 over hypotenuse root 2. What about cos 45 degrees? Cos na adjacent over hypotenuse. Adjacent na 1. Hypotenuse na root 2. What about tan 45 degrees? Tan na opposite over adjacent. Opposite na 1. Adjacent na still 1 over 1. So this one na just 1. Now when we don't get our special angles, make we compile all of them together. 30 degrees, 45 degrees, and 60 degrees. Sine, cosine, and tangent. So what will be sine 30 degrees? We don't do one before. And 1 over 2. What about cos 30 degrees? Now root 3 over 2. What about tan? Tan na 1 over root 3. What will be sine 45 degrees? Same. 1 over root 2. Cos 45 degrees. Now the same thing. 1 over root 2. And tan 45 degrees. Now 1. What about sine 60 degrees? It is root 3 over 2. Cos 60 degrees. Now 1 over 2. What about tan 60 degrees? Now root 3. These are our special angles. We can use them to solve trigonometry questions that involve 30 degrees, 45 degrees, and 60 degrees without using calculators or without using mathematical tables. Now we don't know the special angles. The next step is to use them to solve real exam problems like WAEC questions. Now that one we will discuss for the next lesson. So subscribe make you for no miss am.